we are going to do a process called completing the square. Now, completing the square is a process that allows us to write a quadratic expression as the square of a binomial. Now, when we say the square of a binomial, we're looking at an expression like this: x plus n, that quantity squared. We have a 5-step process. On the left side, we'll be doing the process. On the right side, we'll be doing an example to show you what I mean when we go through all the steps. First thing we need to do is we need to divide everything by a. Now remember, when you have a quadratic expression, a is the number that's with the x squared term. So in our example here, we need to divide everything by 2. When you divide everything by 2, you end up getting x squared plus 6x plus 5 is equal to 15. Our second step that we need to do is we need to move the constant to the other side and put in a box on both sides of the equation. Well, I'm going to go ahead and rewrite our equation from the previous page up here. So we had x squared plus 6x plus 5 is equal to 15. Well, when we move the constant, our constant is the term without a variable. So I need to subtract 5 from both sides. And I also need to put in this empty box. So when I subtract 5 from both sides, these 5's cancel each other out, and 15 minus 5 is where this 10 comes from. So step 2, move the constant and put a box on both sides of the equation. Step 3, we need to find the value of b over 2. Well, now remember, b is always the number with the x term. So in this case, our b is a positive 6. So we end up having 6 over 2, which reduces down to 3. We're going to use that number in step 4. So step 4 says add b over 2 squared in each box. Well, our b over 2 was this 3 right here. We need to square it. 3 squared is 9. And that's what goes inside each of these boxes. Okay, step 5 says we're going to simplify it, and we're going to write it as that binomial squared, and then it's going to be equal to some number. Well, when we're simplifying this, what we're actually doing is factoring it. So if I were to go and factor this equation right here, it would turn out to be x plus, well, if you look at our formula here, it says we have to have our b over 2 in the parentheses. b over 2 was up here in step 3. Our b over 2 turned out to be a 3. So we would end up with x plus 3, that quantity squared, is equal to, and then to get our number on the other side, we simplify our 10 plus 9 and get our 19. And there we've completed the square because we've gotten our quadratic equation written as the square of a binomial. Okay, now if you look at what we ended up with, we had x plus 3, that quantity squared, equals 19. That's really, really close to vertex form. Remember that our vertex form looks like a times the quantity x minus h squared plus k. Well, the reason we're close to vertex form is because we have that quantity squared. What we would need to do is move the 19 over. It would give us a little bit closer form for vertex form. The only difference now would be instead of a 0, if we're actually writing something in vertex form, we would end up with a y there. But do you see how the setup is very, very close to vertex form? So anytime that you need to write an equation in vertex form, you need to complete the square. You might want to write that down. Okay, now we're going to look at how we can use completing the square to solve quadratics. We are going to start with 3x squared minus 8x plus 12 is equal to 0. And we're just going to follow the steps that we went through previously. So the first thing I need to do is divide by a. Well, in this case, my a is a 3. When I divide by 3, I end up with x squared minus 8/3 x plus 4 is equal to 0, because 0 divided by 3 is still 0. So that would be step 1. Step 2 says I need to move the constant and put a box in there. Well, in this case, my constant is the 4, so since it's a plus 4, I need to minus 4 from both sides. And I end up with x squared minus 8/3 x plus a box is equal to negative 4 plus a box. Oops, sorry. Step 3 says I need to find b over 2. Well, in this case, my b is negative 8/3, and I need to divide that by 2. Well, since I have a fraction, I'm going to write it sideways, so I end up with negative 8/3 divided by 2. Remember, when you're dividing fractions, you multiply by the reciprocal. So I'm going to have negative 8/3 times 1 over 2, which will end up giving me negative 8 over 6. I'm going to reduce that down to negative 4 over 3. So my b over 2 turns out to be negative 4 over 3. Step 4, we square that. We have to do our b over 2 squared. So I'm going to take negative 4 over 3 squared. Well, now remember, when you square something, that's multiplying it by itself. So I have negative 4 over 3 times negative 4 over 3. Multiply the top, and I get positive 16. Multiply the bottom, and I get a positive 9. So my b over 2 squared ends up being 16/9, and that's what goes inside these boxes up here. So my equation ends up being x squared minus 8/3 x plus 16 over 9 is equal to negative 4 plus 16 over 9. So you've got to put that 16 over 9 in each of those boxes. Okay, my step 5 is to simplify, or to factor it, basically. So when I look at my equation, which I'm working with this one right here, the left side of this is going to factor into x plus, and we have to go back and pull off that b over 2. Well, our b over 2 was right here in step 3, so it's going to be x plus negative 4 over 3, that quantity squared, is equal to, and now we go ahead and add those two together. Now remember, when you add, you have to have a common denominator. Add these together and you end up with negative 20 over 9. Okay, we haven't actually solved the problem yet. All we've done is completed the square. If you look back at what the problem asks us to do, it wants us to solve it, which means we need to get x by itself. If you look at what we end up with down here in our 5th step, we have x in only one spot. So by completing the square, we take x from being in 2 spots to having x in only 1 spot, which means we can use algebra to solve it. So now I'm just going to undo everything that's over here by my x. First thing I need to do is get rid of that square. So to undo the square, I square root both sides so that they cancel out, and I would be left with x plus negative 4/3 is equal to plus or minus the square root of negative 20 over 9. Now before I go any farther, I'm going to go ahead and simplify that negative 20 over 9. It actually has 2 problems. The first one is there's a negative under the radical. Second problem is we've got a square root in the denominator. But the nice thing is that square root in the denominator is a perfect square. So when I actually take that square root of 9, it turns out to be a 3. To deal with the negative 20, I need to use an I. So I'm going to actually end up with plus or minus. The negative comes out as an I, and then I have the square root of 20. So I've gotten those 2 problems taken care of, but now as I look at this, I realize that 20 can be broken down into a perfect square root of 4 and the square root of 5. Well, the square root of 4 is 2, so the square root of 20 is actually 2 square roots of 5. So at this point, I am left with a plus or minus 2i square roots of 5 all divided by 3. and I still have my x plus negative 4/3 over here. We are almost done at this point because our x is almost by itself. So to get rid of that negative 4/3 there, we need to add 4/3 to both sides. And I'm going to go back to the top of the page to write our final answer. When we actually write this out, we are going to have x equals, I'm going to put the 4/3 in front because that's the real part of our complex number and it should go in front. So we have 4/3 plus or minus 2i square roots of 5 divided by 3. So it turns out to be kind of an interesting looking answer from our completing the square process.